Hello, beautiful humans. Today we are going to learn about complex fractions. I know you really loved fractions to start with, so we went ahead and made them complex, which really just means better. All right, a complex fraction is a fraction in which the numerator and denominator both contain fractions. It's a fraction within a fraction within a fraction within a fraction. Oh, I know you're excited. You can't wait. Okay, thanks. So, to simplify a complex fraction means to rewrite as a single fraction with no fractions in the numerator or denominator. So, here are our steps. We will talk about those as we do examples. So, quick note. You do not have to watch the whole video, but I would recommend watching numbers 1, 3, and 9 at a minimum. These are different types of problems that introduce important obstacles or important, unique cases, things like that. So number 1 is going to introduce you to one type, 3 is going to introduce you to another type, and 9 is going to introduce you to whoa, what the heck is this? This is hard kind of problem. So at least watch those 3. If you think you're a master after that, then go for it. Otherwise, stick around for all the odds in this video. Numero uno. We have a over 2, all divided by a squared over 4. A fraction and a fraction within a fraction. Wow. Okay. So the first thing that I'm going to do is notice that, or, remind myself that a fraction bar just means division. So we're going to rewrite this as a over 2 divided by a squared over 4. Now, suddenly, this looks exactly like problems we've already done. When we divide fractions, we multiply by the reciprocal. So we keep the first part the same, change it to multiplication, and flip the second one. So 4 over a squared. So keep it, switch, switch. All right, so now we have a times 4 is 4a, 2 times a squared is 2a squared. And this is going to reduce to 2 over a. Guys, that was way more simple than we thought it would be, am I right? So let's make it a little more complicated. After all, we did call them complex. All right, first, let's just rewrite it because honestly, why did we stack all this whenever we could have written it much easier? 18p over 8p minus 2 divided by 4p squared over 4p minus 1. So whenever we do that, we keep the first one the same, multiply, and flip. All right, so now when we're multiplying stuff like this, we want to remember that these are individual units, and it's always important to factor everything. So 4p minus 1 just is what it is. So factored, but this guy, we can do 2 on the outside and get 4p minus 1. So this is going to be 18p times 4p minus 1 all over 2 times 4p minus 1 times 4p squared. Well, our 4p minus 1 and 4p minus 1 will cancel. Let's just rewrite to keep things from getting cluttered. We have 18p on top still. 2 times 4p squared is 8p squared. All right, so now we just have a monomial over a monomial, which is pretty simple to simplify. We're going to get 9 over 4p as our answer. All right, my overachievers, this is where you can skip ahead to number 9 if you're feeling froggy. All right, number 5, 7c plus 35 over c plus 5 over c squared. Whew, that's a lot. What I'm going to do this time is, actually, no, I'm not going to do anything this time. Sorry. I'm going to do it exactly the same. Except I am going to skip the division step because, it's just rewriting it like 73 times. So we're going to do the first one, the top one, which is 7c plus 35 over c. Change it to multiplication and then flip the bottom. So c squared over c plus 5. Now, 7c plus 5 can be reduced, or 7c plus 35 can be reduced to 7 times c plus 5. So this is going to give us 7 times c plus 5 times c squared over c times c plus 5. C plus 5s will cancel. C squared over c. This c will go away, and this c will just become, or c squared will just become c. And if we look, all we're left with is 7 and c. And that's your answer. All right, so let's try number 7 now. Remember that this is, anytime you have like not a fraction, you can put it over 1 to make it a fraction. So this guy is going to equal 15 minus 15r over 15r squared times, flip this, 1 over 12r minus 12. So let's do some factoring. This guy can be changed to 15 times 1 minus r, and this guy can be changed to 12 times r minus 1. So we'll rewrite this as 15 times 1 minus r times 1 over 15r squared times 12 times r minus 1. Now, remember that when we have a minus b over b minus a, those can cancel, but we have to multiply by -1. The 15s can cancel. 1 doesn't change anything, like 1 times something is just itself. So we're only left with -1 over these two. -1 over 12r squared. Okay, number 9. This is the one where we introduce something new and scary. We now have subtraction in the numerator. We have 3 fractions turned into 1 fraction. This is insane. All right, so what we're going to do is take only the numerator, and we are going to do that subtraction. We're going to take care of that first. So we need to pick our LCD. So we can write it over here somewhere, whatever makes you happy. 3 and x, we're going to have a least common denominator of 3x. So we have x over 3 times something minus 3 over x times something. To get 3 to turn into 3x, we need to multiply by x. To get x to turn into 3x, we have to multiply by 3. So this is going to equal x squared minus 9 over 3x. We multiply these, subtraction in the middle, LCD on the bottom. All right, so when we rewrite it, we're using this fraction over this fraction. So let's do x squared minus 9 over 3x times, flip this, x over x minus 3. Now, we want to factor this. It's the difference of 2 perfect squares. And we know that when we multiply these, it just becomes one big fraction. So instead of rewriting, let's get some stuff out of the way. X minus 3's can cancel. X's can cancel. And we are left with x plus 3 over 3. And that's it, guys. I've got this one and 2 more for you. So let's start with the bottom. This one's going to take a little bit of figuring. So this guy reduces to 4 times n minus 4. This is n minus 4, so our LCD is going to be 4 times n minus 4. So when we go to do this subtraction and get that out of the way, we have 20 over n minus 4 times something minus 5 over 4 times n minus 4 times something. Well, the second one is already our LCD. So we just multiply it by 1 or don't do anything, whatever you want to call it. And to change the first one to the LCD, we need to multiply by 4. So 20 times 4 is 80, minus 5 times 1 is 5, over our LCD. 80 minus 5 is 75, and let's go ahead and bring our LCD over. So this is our new bottom fraction. Okay, it's our new denominator. So we will now rewrite as multiplication. So we have 5/4 times, and then this one's on the bottom, so we're going to switch those two. 4 times n minus 4 over 75. So we see that our 4's will cancel. 5 over 75 is going to reduce to 1 over, I talked too fast, 15. So we're just going to be left with n minus 4 over 15. Number 13 has addition and subtraction in the numerator and denominator, because why not? Why wouldn't we? So let's just take it one at a time. The numerator, the LCD, is going to end up being a squared b squared. So this is going to give us 1 over a squared times something minus 1 over b squared times something. We'll have to multiply the first one by b squared and the second one by a squared. So we're going to get b squared minus a squared over a squared b squared for our top fraction. All right, on the bottom, our LCD is going to be AB. So we have 1 over b times something plus 1 over a times something. We have to multiply the first one by a and the second one by b, and we will get a plus b over ab. So now this is our new problem. So we can convert that to multiplication. We're going to have b squared minus a squared over a squared b squared times, and then flip the bottom one, ab over a plus b. So let's factor and rewrite this. B squared minus a squared is a difference of two perfect squares. So it's going to factor to b plus a times b minus a. And then we also have to multiply that by the ab in the second part. Then we're going to divide this by a squared b squared times a plus b. All right, b plus a and a plus b are the same thing. Those cancel. And then we have an AB in the top and an AB squared in the bottom, or a squared B squared. So what we can do is we can take away one of each. So we can take away the A and cancel the 2, take away the B and cancel the 2. So this leaves us with B minus A divided by AB. Now for our last problem. Okay. The LCD for the numerator is 4v. So this is going to equal 1 over 4 times something plus 1 over 4v. That's already the LCD, so we don't have to multiply anything. We need to multiply the first one by v over v. So we are going to get v plus 1 over 4v. Good deal. The LCD for the bottom one is also 4v. Wowzers, so cool. So this one's going to give us 1 over v times 4 over 4 plus 1 over 4 times v over v, which will give us 4 plus v over 4v. So let's see what happens. We're going to get v plus 1 over 4v times the second one flipped, so 4v over 4 plus v. Cancel, cancel. V plus 1 over 4 plus v. Congratulations, you are done with all the odd problems. You may now go complete all of the evens. Thank you and have a great day.